Hello, and thank you for staying tuned to Empowered Learning. This particular lesson, what we're going to do is discuss what's called the fundamental counting principle. And so I like to think of this particular principle as a more common sense type principle, but we're going to actually formalize it and show you how it could be used in some everyday applications as well as some applications that you may not have thought of. Okay, so let's start out. Fundamental counting principle. So we see the purpose of it is to give the number of ways performing two or more tasks, okay? And so the key to this is knowing that when we are trying to figure out how many ways two or more tasks can be done, the assumption is that one task has to follow another task. So we have to have task 1 first, and then task 2, and then if there's a task 3, that has to happen. They have to happen in order, okay? So assuming that to be true here, we'll see that if task A can be done M different ways, and then task B can be done N different ways, then the fundamental counting principle says that we can do task A followed by task B, M times N different ways, okay? And so by knowing that this says followed by task A followed by task B, that is implying that order matters. And so because of that, our fundamental counting principle, whenever we see problems like that, we inherently know that that's a version of a permutation type problem, okay? And so I have two examples here to sort of illustrate sort of the everyday life type of example versus one where you may not have thought that this was actually an actual permutation. So let's start with this first one. So we have a guy named Calvin, and he has 5 shirts, he has 2 ties, and 3 pairs of slacks or pants. And so we want to find out how many different outfits does he have if he has this selection to choose from in his closet. So if we look here, we know if he's going to put an outfit together, the first thing he has to do is come up with what shirt he's going to pick. So his task A is going to be pick a shirt. He has 5 different ways of doing that. And so task B is going to be, all right, we want to pick a tie. Well, he's got 2 to choose from. So he's got 2 different ways of doing that. Task C would be, all right, well, what pair of pants is he going to wear? He has 3 to choose from. So he has 3 different ways of doing that. So according to the fundamental counting principle, this says that the total number of outfits that he has, so number total outfits, would be just 5 times 2 times 3, okay? So 5 times 2 times 3, and we know that that ends up being 30. So from those 5 shirts, 2 ties, and 3 pairs of pants, he can come up with 30 different outfits, okay? So next, we want to take this example here, and we want to take the word breath, and we want to figure out how many different permutations of this particular word can we come up with. So what do we mean by that? When we say permutations, we mean how many different arrangements where the order actually matters. And so again, if we're talking about a word, of course, the order in which the letters come in a word actually matters, okay? So if we look here, we have 1, 2, 3, 4, 5, 6, 7 different letters. And if we notice, all of them are distinct. So here we know that we can only come up with 7-letter words. So here we notice that out of these 7 letters here, if we wanted to choose what's going to be the first letter, we have 7 different choices, okay? But then after we chose that, we can't choose it again. So let's say we chose B, and then we say, all right, well, how many letters do I have left to choose for the second space in the word, or the second letter in the word? And as you see here, we have 6. And then here we have 5 left, and then 4 left, and then 3 left, and then 2 left, and then 1 left. And so task A, task B, task C, task D, task E, task F, task G. So we have all those different tasks. And so since we had to do them one followed by the other, we know that we need to multiply all this together here. So if we look at this, we know that 7 times 6 times 5 times 4 times 3 times 2 times 1 is just 7 factorial. And it turns out that 7 factorial is 5,040. So we have 5,040 different ways that we can take the word breath and rearrange it.